Hello everyone and welcome to a new video. This video is first of what will hopefully become a series of videos that will run in parallel with the other longer full project videos that you usually see on this channel. And the idea for this series is quite simple. In a short video, I will share interesting modules and other pieces of electronic that I have found online. Briefly explain how they work and how or where you could use them. Before we start, just a quick disclaimer, none of the items shown here are sponsored in any way, so everything you see in these videos I have purchased myself with my own money. So with that out of the way, let's get to it. The first item on the list is a USB-C power delivery adapter. These things are awesome and you can see a couple of them here in different form factors, but they all basically do the same thing, which is to allow you to power a non-USB-C device from a USB-C power delivery charger. These might look like they're completely passive in just switching from one connector to another, but inside there is actually a tiny chip that will negotiate or talk with your USB PD charger to activate the correct charging profile. For example, this one will try to activate 20 volts on your USB charger and then it will pass that voltage onto the other end of the connector. One of the situations where this can come in handy is, for example, I have this older Lenovo laptop and it uses one of these yellow rectangular connectors for power. And instead of using this very bulky laptop charger, I can get one of these adapters that allow me to connect a USB-C power on one end and it will convert that to appropriate voltage for my laptop on the other end. This means that now I can power my laptop from any USB-C charger, but also now I can power my laptop from my power bank when I'm on the move. And another use case is for me to power one of these small form factor PCs. To use these modules, you have to make sure that your USB charger supports PD and that it has a voltage profile that your adapter requires, and you're good to go. And as I said, these adapters exist in various shapes and formats, so you can get them for pretty much any device you have. Very similar to the previous item, this module also converts USB-C power to 9, 12 or whatever voltage your circuit requires. However, this form factor and the ability to choose a fixed voltage is nice when you want to power your custom electronics, maybe retrofit a USB charger into an older device or power your DIY setup from a USB-C charger. There are a couple of variants of this module, but they all basically work the same. There is a trigger chip on board that will handle USB power negotiation and trigger the correct profile. Usually on the board there is a way for you to select which voltage you want on the output. This one uses dip switches, but there are versions where you solder a resistor or just bridge two contacts. Depending on your use case, you might prefer one where you can easily change the output voltage by just moving these switches. Or maybe you want to make sure voltage cannot be accidentally changed, in which case you can use one of these where you need to solder a resistor or where you need to bridge two contacts. These boards are very similar to the previous one, however, these ones expect you to make your own connection on the other end. This can come in very handy when I want to power something like my camera slider or my LED light board that have a terminal connector for power input. This is actually how I used to power my solder fume exhaust fan before I built the OpenFan Micro. For the previous two items, we had USB-C power delivery charger available and we wanted to leverage it to get a fixed DC voltage so we can power a non-USB-C device. But what if you have a power supply that outputs a fixed 12 or 20 volts and you would like to charge a USB-C PD device on the other end, which is basically make your own USB PD charger? Then you need something like this DC to USB PD module. This module is basically the opposite of the previous two items. There are multiple versions of this module available, but the idea is the same. This module handles USB PD negotiation with the device that wants to be charged, as well as regulating the input voltage onto the USB output. So we just provide a fixed voltage from our power supply and the module will basically work as the USB PD charger. This means it will present itself as a USB PD charger to whichever device you connect here, whether it's your phone or a laptop, and allow it to choose from different power profiles. The list of available profiles will depend on the input voltage and the chip that it's used, basically if the chip supports buck boost or just the buck topology. And here buck topology basically means that it can provide output voltage that is either equal or lower to what it has on the input, while boost means it can also provide output voltage that is higher than what it has on the input. This module that I have uses XPM52C chip, which is 65 watt USB PD multi-protocol buck chip. Here we can provide a fixed DC voltage to the module. Anything from 8 to 30 volts will work. The module will first detect what voltage it has on the input and based on that figure out what USB PD profiles it can support. Once you connect the USB PD device, they will negotiate which profile to use, after which module will regulate the input voltage down to whatever is requested by the USB PD device. These modules are quite handy and can be used in many different applications. They basically allow you to make your own USB PD charger wherever you have a DC voltage source, which is quite cool. Right now I'm working on a project that will power my entire home lab using something similar to these modules. So you might want to subscribe and bell so you don't miss when that video goes live. USB-C power delivery is awesome because it allows you to charge your device from multiple different power profiles. But knowing which profiles are available or not available is not always that obvious, especially since there are quite a few of them and there is no requirement that all of them have to be supported at the same time. And you can't really blame the manufacturers for not spelling out every supported profile, especially on more compact chargers like this one. However, sometimes it can be useful to know which profiles are actually supported, and that's where a tool like this comes in very handy. This is a USB PD profile analyzer, and when you connect it to a USB PD capable charger, it will show you the bus voltage, current and power draw, which profiles is selected, and so on. But the really useful feature is this one. You can ask it to interrogate the charger and list all the available profiles. Here I have my USB charging brick and also my power bank. To be honest, I have no idea which profiles they support. We can check what is printed on the back of the device to get some idea. But if we connect this little tool, it will list all the profiles these devices support. And as I said, having something like this can be very useful when you want to know which profiles are actually supported or play around with the fast charging and USB-C power delivery. Sometimes you just want to know how much power your device is drawing while charging, and this is where these tiny little USB-C power meters come in very handy. There are multiple versions available, but this one that I have here shows only the power draw. There are more fancy versions available that show power, voltage and current draw, so you can choose whichever one you like. The way they work is you put them in between your USB charger and the device you are trying to charge. Inside, they have a chip that will measure the USB voltage and the current draw, multiply those two and you get the power draw. And then they display those values on this cool little display. Keep in mind that because you add these inline to your charger, they will also extend the rigid part of the cable, and this will also increase the length of the leverage, so just be careful you don't damage your USB connector by exerting too much force on these. As you have probably noticed, all of the items in this video are related to USB-C charging, and this is because I'm working on a cool new project for my home lab. Click subscribe and bell to get notified when that video goes online. But before I wrap up this video, I would love to hear from you. Do you like these kinds of videos and would like to see more of them? And do you have suggestions for cool components that you would like to see here? And with that said, if you did find this video interesting, please consider sharing and liking this video. Or if you didn't like it, feel free to hit that dislike button or let me know down in the comment section. Also, please consider subscribing to my channel, it really helps a lot. That's all for today's video. Mom, thank you for watching. I know you definitely made it this far. And if anybody else has reached this part of the video, thank you, you're amazing. Thank you all for watching. My name is Sasha and I will see you in the next one. Bye!